Here we're going to talk about a diplex match. We're going to introduce the concept of operating modes. We're going to show you how optimization fits into this, and then we'll also talk about the coupling and parasitics. So this is going to wind up being two projects that I go over with you. The first one being this one. So here in this case, we have just a DILA antenna. If I zoom in, the antenna is just connected to a little stub, and then we have our voltage source or our feed right here connecting the antenna terminal down to ground. As you might expect, we ran an FDTD simulation number one here, just to get the unmatched results. And once we had that, we then had that we already designed in terms of the topology. We plugged in the component values and the components and build it all out. And so now we can look at S parameters for this. It's essentially a 2-port network. So we're looking at a 2x2 S parameter matrix. We can look at the reflection coefficients at both port, and we can look at the isolation term or the coupling, the S21. So if I look at the S parameters here across the top in blue and green, actually just blue, this is just showing us the unmatched result, what we got before any matching network was applied. The GPS is down here in band 1, or sorry, GPS band L around 1.6 gigahertz. And so there's a deep match here within that frequency range, not exactly at the L1 band that's shaded, a little bit off to the side. So we can look at adjusting the component values to get that to match. But then in the Wi-Fi band around 2.4 gigahertz, it's not matched very well. Conversely, if we look at the Wi-Fi port, well, then there's a nice match in the Wi-Fi band, but then not in the GPS port. So that's desirable. And then this yellow graph is showing us, so this is just showing us the isolation of the GPS port from the Wi-Fi port. GPS receivers are sensitive, and so we don't want a lot of interference coming from the Wi-Fi port and interacting in with our GPS. So these are the S parameter results that we get whenever we run the simulation for this schematic as it's built. The system efficiency is also a result that's available and is of interest. In order to calculate system efficiency, we can only have one port active at a time. So if we're interested in the system efficiency for the GPS port being active, well, then we need to come in and edit our Wi-Fi port, so that way it is essentially treated as a 50 load. We can get system efficiency for that result. We can then, undo that, and then double click on our GPS port, set this one inactive, and then we can get system efficiency for the Wi-Fi port being active. It should be, pretty much red light. This is an undesirable workflow, right? Like enabling, disabling, running simulations, looking at results. It will give you the results. Let me just show you what that graph looks like. So here, what we're trying to, let me hit the run button so we have, actually, let me do this. Hit the run button. So now we get the results that we're interested in, where the blue graph is the unmatched system efficiency that we got. And then for the green dots here, this is the system efficiency we would get whenever the GPS port is active and the Wi-Fi port's inactive. And then the red one, this is what we would get when the Wi-Fi port is active and the GPS port is inactive. And so the way, I guess, a more user-friendly way of analyzing these two different states of being on and off or off and on has to do with the use of operating modes. And so within XF, we have this idea of operating modes. Right now, there's an operating mode for the Wi-Fi mode, a second one for the GPS mode. And if I look at their settings, I can see that for the GPS mode, we have the Wi-Fi port, and it's active set to false. The GPS port is active set to true. Conversely, if we look at the Wi-Fi mode, well, then it's the opposite. And so through operating modes, we have the ability to define both of those states at the same time, which means I can run my results, I can run my circuit solver, I can come into my results tab, and I have both the GPS mode and the Wi-Fi mode available at the same time. And so then I have system efficiency available, and so I can grab the system efficiency for both of those modes and plot them and visualize them. So if I wanted to come in here and change this inductance value, well, then I could just change the inductance value, update my results, and get both mode and Wi-Fi mode available at the same time. So that's what operating modes is doing for me, allowing me to analyze multiple states of my schematic all at the same time. We can also tie this in with design goals. And so in this case, we have 3 design goals set up. The first one has to do with system efficiency for the Wi-Fi band, where we're looking at a result that's greater than -3 dB over that range. Similarly, we have a similar design goal set up for the GPS band, greater than 3 dB over the GPS range. And then we have another goal here, which is based on S12, and we're looking at that isolation being better than -20 dB. And so if I look at my goal report, I can see that my isolation was good.